sometimes it's the machine too. You can,
Adjust it.
yeah. This machine is bad readings. Way over. And typically, there's a couple of things you can try. What it usually is, yeah.
There's something
If
definitely
it's,
wrong.
yeah. It's not the cord giving you an issue, which sometimes it is. Just by wiggling the cord, you'll see it didn't change. You know, that's not what's going on. The other thing is that a lot of times the sound head or the holder is pressing down on this. You'll see if you press down on it, it's going to change. You know, and sometimes that happens. Something happened. Home's not
There's
in.
stuff to do.
Exactly.
Before you freak out and say,
Exactly. You know, and if
troubleshooting.
yeah, you know, if that all seems to be in place, and then it does, you know, things are, you know, interfering with that, you got a calibration issue, you know. And I will show you how to calibrate this machine. Buttons to start, and then these two buttons here. Make sure your meter's on zero. Zero down. And make your reading. Start seeing these numbers start to fluctuate down here as it's searching.
So this is basically searching for a problem.
It's
Kind of troubleshooting itself.
It's troubleshooting itself, yeah, and it's looking for calibration information.
Mhm.
You
And
know,
then it gives you a reading. Just tells you what's wrong.
exactly. And it starts you off. You'll see, because there's boards in here. There's also a board in the sound bit itself, so it's communicating back and forth with the sound head, trying to find the right frequencies.
That's good.
So now it it's telling you to set your meter to 4 watts. Okay?
Change it back.
What most people do is they'll start spinning the dial or looking at the machine, expecting it to start showing wattage.
Okay.
No, pay attention to your meter. As you're ramping it up, you'll notice this starts going up. As soon as this meter
watts you said?
reaches 4 watts, and it comes up quickly too. Usually right up around 300 to something, 300 is where you'll start seeing it start getting up close. If you spin it too quick, you'll miss it. It's kind of a pain to have to go back.
It's almost there.
It's very easy to go past it. Want to try it out 4. Just gonna wait, make sure it's stable. Have you do it on 3.3 minutes. This way. Again, looking for 4 watts. 3.3 minutes. I'm not paying attention. I've ramped it up. I'm either showing 10 watts or oh crap. All the way back down. Yeah. Kind of walks you through it. Doesn't calibrate it again, you're still off.
Get a place to turn this thing back.
No, it's the board and it's and I'll show you what you need to do.
These replace the boards too.
Oh yeah, they're real simple.
That should be. That's good.
Yeah, we're still within the 10%. Fly out of your machine.
So freaking sensitive.
Yeah, they are. Yeah, you'll get some
patient monitor testing can be quicker and easier than ever before with ProSim 8 from Fluke Biomedical. We're going to do a patient monitor test. We're going to try and do a complete but quick test of this patient monitor. The parameters we're going to test are ECG rate, respiratory rate, invasive blood pressure, channel 1. We're going to do a cuff blood pressure and IBP measurement and oximetry. We're going to try and get all of this testing done in under 5 minutes. As you can see, there's a digital clock shown in the lower left-hand corner of the patient monitor display. So you can be your own judge as to whether we can get through this test within 5 minutes or not. So as I begin the test, we are already connected to the device under test. All of the connections have been made ahead of time, including the NIBP cuff. And we are going to zero our invasive blood pressure transducers on the patient monitor at the very first step of what we do, followed by a selection of a simulation of all coordinated patient parameters. We'll do hypertensive first, followed by normal, followed by hypotensive, in order to assess whether we have a performing patient monitoring. We will compare the displayed values on the ProSim 8 against what's displayed on the patient monitor at each set of simulated parameters. Are you ready? Let's begin now. First thing I'm going to do is 0P1. It is at 0. And now what I'm going to do is pick hypertensive. And the simulation will already begin, so I'm going to start a cuff blood pressure reading. In this case, we're looking for an ECG rate of 130 beats per minute, respiratory rate of 40. We're looking for an invasive blood pressure display of 200 over 150. We're looking for NIBP of 200 over 150 with a mean of 167, and an SpO2 reading of 90. And it looks to me like we've got all of those on the patient monitor. 130, invasive blood pressure 198 over 149 with a mean of 167, and we have 90 O2 sat and 197 over 142 with a mean of 165 on the cuff. Let's move to normal. The normal simulation includes heart rate, ECG rate of 60 beats per minute, a respiratory rate of 20 breaths per minute, invasive blood pressure of 120 over 80, a cuff blood pressure of 120 over 80 with a mean of 93, and SpO2 at 100% O2 sat. As you can see, the patient monitor is already displaying 60 beats per minute for heart rate. It's gotten 119 over 79 with a mean of 93 for invasive blood pressure. And the cuff is making its measurement now for the O2 sat, or for the NIBP reading. O2 sat is 100%. There we go, 121 over 77 versus 120 over 80, pretty good. We'll go to hypotensive now and start another cuff measurement. We're looking for an ECG rate of 40 beats per minute, respiratory rate of 15 breaths per minute, and invasive blood pressure measurement of 50 over 20, and cuff blood pressure of 50 over 20 with a mean of 30, and an O2 sat of 97%. You can see that the ECG rate on the monitor is already 40. Our invasive blood pressure is 50 over 19, very close to 50 over 20. Our cuff is working on getting its measurement, and the O2 sat is 97, right on with what we asked for, what we're simulating. We started at 18:55 and 44 or 45 seconds, and we're going to finish very shortly here. Done. And we have good values. As you can see, it is possible to do a complete, quick assessment of patient monitor performance using ProSim 8 and front panel controls in under 5 minutes.
Hello everyone, we are manufacturing medical cables for 8 years. Now we are checking the accuracy of the encoder messages and extension cable. Encoder 14 pin and 9 pin. Okay. We connect the cable with the machine. SPO2 connect with the extension cable. This is the SPO2 simulated to check the accuracy of it. Set the oxygen saturation in oxygen saturation in 98, and we need to check the machine to see whether it is in 98. Yes, great. So this true cable is accurate.
Hello everybody, I'm going to be showing you how to set up a ESU electrosurgical unit to a ESA, a electrosurgical analyzer, in order to perform any testing. The hardest part of testing an ESU to an ESA is actually making all of the connections. The actual ESA itself has a menu that's pretty straightforward, pretty easy to use, so long as you get the connections down right, you should be good to go. In order to start connecting, I'm going to use some cords that are color coordinated here. I'm going to use yellow as cut. I'm going to connect that. I'm going to connect it to the monopolar port designated for cut. We'll use blue for coag. And again, I will plug that into the port designated for coag on the monopolar side. Last connection here is going to be red. That's my hot electrode, and I'm going to connect that to the variable high. There's one more connection I need to make as far as these cords go, and I'm going to connect the common to the variable high. Next step, we want to connect our return electrode. Because we're using monopolar, it's not actually going to work unless the return electrode is activated. Connect that there. On the electrosurgical analyzer, we connect the return electrode to the CQM port. So I have all my connections made. The only connection you don't see, on the back of my ESU, I have a foot switch that's connected. Now this foot switch, I'm not actually going to be pressing the pedals when I do the testing. The foot switch automatically engages the ESU when I go and start the test. So on the main menu, we have a couple different options on the ESA. We're going to go ahead and do the generator output test. When the generator output test shows up, you have a couple different options. You have load and delay. Fluke recommends that you use 200 ohms for a load when doing this testing, and they recommend that the delay is 1 second. Some other options you have, you can do a cut or coag depending on what type of test you want. You can do a start single test or a start continuous test. And last, you can save your data on the right. Now when we start our test, all of the information that we want is going to be on the right side. We're going to get power measured in watts, we're going to get current measured in milliamps, we're going to get peak to peak voltage, and we're going to get a crest factor. So with everything set to go, all I need to do is hit start single. We are set for cut. That's going to be good. Let's go ahead and start this. Before I start, know that my ESU is actually set to 100 on the cut side. So let's see what wattage we get with 200 ohms, 86.2 watts. If I wanted to measure the coax side, just select coax here and start single again. My coax was set to 80 on the ESU, and you can see I have the wattage of 66.8 for power. Our current's at 578, peak-to-peak voltage at 747, and a crest factor of 3.2. So this is one way to connect the two devices together. I'm actually going to show you another way. And what we need to do is we actually need to disconnect most of these. I'm going to leave common and the variable high jumped, and I'm going to leave my ground electrode, or return electrode, connected as well. So what I'm doing now is I'm grabbing a monopolar pen. I'm going to connect that pen, as we normally would, into the monopolar port. But instead of having a blade at the end, like I was actually going to be using the electrosurgical pen here, I'm actually going to be taking a cord that has a pin on the end. I'm going to be sticking that into the ESU pen. I'm going to take the other end and I'm going to connect it to any port, cut or coag, depending on what test we're doing. I have cut selected on the analyzer, so I'm just going to go ahead and connect that to the cut jack there. The difference between this test and the test with the foot switch is that when I start the test, I actually need to hit the appropriate button depending on what type of test we're doing. Because we're doing cut, I'll be hitting the yellow cut button. And as you can see, the numbers came up just as you would with the foot switch. No difference. 87.9 watts, 663 milliamps, etc. If I wanted to do coag, I would just change the coag here. I would change my port to the coag port, and I'd be hitting the coag button. And there's our information displayed there. So as I mentioned before, setting up the two devices is the most important and probably most difficult part of doing any sort of testing. Actually using the electrosurgical analyzer itself is pretty straightforward and easy. And that's it, guys. Thank you very much.
Hi, my name is Sławian Angelov and I'm biomedical equipment technician. The IDA5 is really accurate and fast. We use Hospira infusion pumps. Before we used the IDA5, we didn't have any idea what is the percentage of air. And now with the analyzer, it's way easier to find the exact numbers. You can precisely see what is the volume, what is the flow, and what is the pressure. And then you know if the pump works right or not. You can hook up 4 pumps in the same time. The IDA5, it just does the job. I think people will be really surprised to find how easier their job can be once they use it. You have 2 different versions. The IDA5 is more for like working on your bench. It's not as easy to transport, but you have a lighter version for that. IDA1S, it's very light and it's portable. You can transfer it like very easy to different places. We have a biomed in our department that goes to different clinics. He has to travel there. He's so excited because he can just take it, do his measurements, come back. It's simple as that. You have a touch screen. It's really easy to navigate. being a biomed, you always have to go really fast. So equipment like that helps you in a big way. I always think of the biomedical, they move with technology. And these days technology goes so fast. It's probably the most advanced infusion pump equipment that I used so far in my career. It makes your job way easier. I love it.